Right, recording started. Then share my screen. So bear with me, I'm not very good at with this thing. Can you see my screen now?
Yes.
Thank you.
Yeah, looks good.
Okay, good. So we've scheduled for about an hour, and if we go over a little bit, we do have a meeting booked for it. So here's what I'd like to be able to cover. We'll start with some kind of a hardware description, and it's purely what we have in Dell's lab. But it's, there's nothing special. It should be very typical. We are trying to go through few from installation and all the way to the setup of the part. We're going to skip a few part of it because it takes too long for those steps. Those will be covered with a screenshot instead. And we'd like to be able to run some fun tests, but the installation process itself is going to run a long time. So instead, what we do is we have a pre-installed Foreman instance. And so we can actually swap in the middle of it and then run the fun test on the Foreman instance. So that's the trick we're doing. Hopefully we'll finish that within an hour. Okay. Let me start on the hardware setup. So in high level, essentially, all the chain for the firewall to get through to a Tor switch, and from there we have two parts, 1 and 2, and really just one part public network and one for lights out management that you can both of them you can access from a remote location through a firewall, and that's the two parts right there. So for each case we have a jump server which is separate from OpenStack, and we use 3 control nodes and at least 1 compute node for the demo. So the first part is running for fuel, and it has requires 4 separate networks. These are IP networks, and so we have 1 admin for Pixie boot, and 1 public network so that you can have internet access, etc., and storage and the management network. In this part, we use VLAN tagging. So,
hey, Wenjing,
yes.
Are you intending to be sharing something? I don't know if other people are seeing it, but I'm not seeing it.
Okay. Are you seeing a slide which says?
Is anybody else seeing it here?
Yeah, Brian, I see it.
Okay.
I can see it too.
All right, good.
All right, you need to work on that. Okay, so the color-coded ones really is how the ports are used, and if you look at the bottom half, there are 3 bundles. Those are the VLANs. Okay, so it's really translating to 3 physical ports: 1 for the public access, 1 for really the private functions, everything else, and another one we use for lights out management. Okay. Let me go to the next slide. The Foreman installation, the requirements are somewhat different. I think the main thing is that we don't use VLANs, or at least tag VLANs. So the same kind of requirement, very similar, and you will see actually 4 physical ports used here, and these are also color-coded lines here. So again, the admin for boot, you have a private one for everything else, and a public for internet access, another one for out. Okay, So the next step with that, I'm going to see if I can transfer to Norman. Are you on the call?
Uh, yes, I'm on the call, Vincent. So can I share my screen now? Can I be the presenter?
Yeah, let me see. How do I do that? I think I need to click your name and make you a presenter. Make it a presenter. All right. Go ahead. You're a presenter now.
Okay, thank you. I just shared my screen. Can you see it?
Yes, I can.
Okay, I'm going to go to the Fuel VM setup part now. Okay, so the first thing that we need to do is to fetch the fuel ISO from the Arno website. Uh, what we plan to do here is that we are going to run the fuel ISO in a VM on the jump server. For that, we used a simple hypervisor. You can use VirtualBox or KVM or anything that you may like. We used KVM through Virtual Machine Manager and loaded the fuel ISO. And again, the general settings that one needs to do when setting up a VM, we gave it around about 8 GBs of memory for CPUs. And here comes a very important part of setting up the VM. So we need to bridge the first virtual port of the VM to the jump server's second port. This will be used as the fuel admin network. We also need to add an additional virtual VM port. We bridge this virtual port to the jump server's public port, which in our case is ETH0. As you can see here, our jump server's ETH0 is the public port for the jump server. We bridge it to an additional virtual port for the VM. After this is done, we can begin the installation for our virtual machine, the fuel installation actually. Another important thing that we need to do is that once the fuel installation begins, we need to press the tab button so that we can change a slide setting here. What we really need to do is to change the show menu option from no to yes. We need to do this because so that we could change the public network settings so that the fuel VM can be remotely accessed. So once we do these settings, we can start the fuel installation. And after a few minutes, we get this screen where we are supposed to do a few networking settings. The only thing that we really need to do here is that on our ETH1 port, which is actually connected to the jump server's public port, we need to give the network settings for the public network. So we gave our IP address, our default gateway for the public network so that the fuel VM can be accessed remotely. Once this is done, we begin the installation, and it takes around about, another step that was in between is to save and continue so that the installation can begin. The fuel installation kicks off, and after around about 30 to 40 minutes, the fuel installation is completed, and we get this screen. What we can really see here is that fuel UI is available on on the following IP address, and we can begin the port deployment. So this is how we set up the fuel VM. Does anyone have any questions? Okay, I guess none. I'll move on. So now we move on to deploying a pod using the OPNFV Fuel ISO. As you can see here, that in our last screen, it gave us a web. a web address so that we can access the Fuel GUI. I'm going to put in this address in my web browser so that we can access the Fuel GUI. Okay, so here we have our Fuel GUI, and going back to the slideshow. An important thing that we need to do before deploying the pod is to ensure that our pod nodes are PXE booted. For this, we need to go to the BIOS settings for the pods that are to be the nodes that are to be deployed. We are going to enable PXE booting option for the port that is connected to the admin Fuel network. As you can see here, we just changed the PXE network settings in the BIOS and ensure that the first device that the node boots from is this PXE port. So this allows the Fuel GUI to detect any nodes that are available for deployment. I'm going to open my Fuel GUI now, and we can now begin a pod deployment. So as you can see here, I already PXE booted 5 of my server nodes, and they were given notifications here. So beginning the new OpenStack environment, we can give it any name that we want to. I'll give it Dell. Oh, sorry. Dell OPNFV Arno. We have an option between choosing 2 operating systems to be installed on the nodes. We can either use Ubuntu or we can use CentOS 6.5. In this setup, we are going to use Ubuntu. We are going to select the option of multi-node with HA. And on the compute nodes, we're going to use KVM as the hypervisor because we are doing bare-metal deployment here. What the Arno installation documents specify is that when setting up the Fuel pod, we need to check this option, neutron with VLAN segmentation default. Ceph is to be chosen as the option for Cinder and default for Glance. We also need to install Ceilometer as one of the additional services. All these options are those that are specified by the Arno documentation for Fuel installation. Once we prick Next, we can now create an OpenStack environment. So here we are. Okay, so the first thing that we need to do here is to add the nodes that were PXE booted into our environment. For this, we need to press on the Add Nodes button. We now, first of all, we need to choose the role that a particular node will have. I'm going to choose the role of controller, along with the role of telemetry MongoDB on 3 nodes. I'm going to choose these 3 nodes. So these 3 nodes will have the roles of controller with the option of telemetry MongoDB on them. I'm going to apply these changes. So now I have 3 controllers in my environment. Now I need to add 2 compute nodes. Again, going back to the Add Nodes button, selecting the role of compute, selecting 2 nodes, and pressing apply changes. So So now we have an environment where we have 3 control nodes and 2 compute nodes. The next thing that I need to do is to ensure that the ports for all these nodes are in the correct order. What I mean by that is I'll configure the interfaces and ensure all of them are on the required ports. In our deployment, we need to ensure that the private network, the storage network, and the management network are all overloaded on a single port, that is ETH1, and we're going to have only the public network on our ETH0 port. I'm going to apply these changes. Once this is done, I need to make a few networking configurations. I'm going to press on the Networks tab. I'm going to, first of all, we need to choose the storage network. Since the storage network is an internal network, we can have any IP we want to. We just need to ensure that we have, oh, I don't know why this is happening. Oh, okay. Anyway, on the storage network, we need to have a certain VLAN tag. What we are having right now is just a bug, not a major bug. We had an earlier environment. We deleted that environment which had this 101 tag. For some reason, it is still stored in its database, so we're having this conflict. So we won't be having this conflict that will disrupt the installation process. So we'll be having the VLAN tag of 101 on the storage network. Next on, we need to change the public network settings. These public network settings will be provided to you by your lab administrator. What you need to give here is the range for public IP addresses that you will have for your pod deployment. In our case, this range goes from our network is 64 subnet 26, and our gateway is 18.0.65. Oh, I see. So the VLAN conflict issue is solved too. I think I was having the same VLAN here as that I was having for the management network. So that's why we were having the issue. So what we need to have here is to have 2 virtual networks on 2 separate VLANs. You need to ensure that your switch that is connected to these ports allows these specific VLANs of these numbers to pass through. Once this is done, you also need to do Neutron L2 configuration. Again, you need to ensure that the ports that you give here, these are all possible, are allowed to pass through your switch. Once this is done, the final thing that we need to do is to allocate our public pool that will be available for OpenStack, for the OpenStack meetings. Again, these will be provided to you by your lab administrator. And change these to once we have made these networking changes, we can save these settings. Oh, I must have made a mistake. Oh, it should be 126 because 127 is the broadcast address. So I hope we're not going to have that error now. No error. So I'm going to press verify networks now. This would take around about 3 to 4 minutes. So I'll move on to a part that is only specific to the OPNFV Arno ISO. Normal fuel ISOs do not need this step. For this step, I'll show you my PowerPoint presentation. What we need to do is go to our Fuel VM and run a few scripts. What these scripts would do is that they will ensure that once our nodes are deployed, they have the ODL files, the ODL scripts that we need to manually run so that ODL could be integrated with our OpenStack Fuel installation. So I'm going to open up my terminal, enter the IP of my Fuel VM. Okay, I'm in now. What we need to do here is first identify what is the environment ID for the environment that we just set up. For this, we need to run the command fuel node list. So the environment ID for the environment that we just set up is 3. We need to go to a specified directory, which is again given in the Arno fuel installation. This directory is only applicable to the fuel Arno ISO. It's not available in the normal fuel that you'll find on the internet. So I'm going to go to the OPNFV directory. I'm going to run the pre-deploy script here with the argument being the cluster ID that we just identified by running the fuel node list command. So I'm going to give the argument of 3 to this script. So once the script is run, it asks us to enter a few settings. First of all, it asks us to enter the DNS servers to go into the etc resolve.conf file for our compute and control nodes. If you do not give an IP address here, it would assume the same DNS server that it had for the fuel VM. In any case, I'm going to give a DNS server IP here, and for yes. Always good to have another backup DNS server. Yes, that's it. Once we are done with entering our IPs, we just need to press enter, and we're done entering for the compute and compute nodes. Now we're done entering for the control nodes. It's asking us to enter the DNS servers for the compute nodes. Again, I'm done entering. I'm going to press enter now. Now it asks if we want to insert any host file additions for our compute and control nodes. We are not specifying any host files for control and compute nodes in our case, so I'm just going to skip this. And at last, it's going to ask for NTP servers, and I'm going to enter the NTP servers. Yes. These are all the settings that we need to specify in the pre-deployment script. Now, the deployment facts have been updated, and we can see if these updates are identified by the Fuel GUI or not. I'm going to go to my Fuel GUI, and I'm going to refresh my page. As you can see that since we ran the deployment script, the deployment parameters for have been updated, and this can be seen here in the line in the Fuel GUI. Before doing the last step, we press the verify networks buttons to ensure that all our networks are configured in the right way or not. We can see that we got a message saying that verification succeeded, so we are good for deployment now. So all the steps to deploy Fuel Arno ISO have been done. We just need to press the deploy changes button and the deployment would start. Deploy. So does anyone have any questions as of now?
Doing very well. Continue, please.
Okay, good. Okay, so as you can see that the nodes are being provisioned with Ubuntu and the installation has begun. This is a very lengthy process that takes around 2 to 3 hours. So going back to my presentation. As you can see, we ran the pre-deployment script that I ran in my terminal. After running the pre-deployment scripts, press the deployment on the GUI, we did that. And after a few hours, hopefully, if all things go well, we're going to get this message on the Fuel GUI that the deployment has been successful and we can access the OpenStack dashboard at this IP address. Okay, so an important point to note here is that once the OpenStack process is done, we need to do a few post-deployment steps. These post-deployment steps are just to start ODL and integrate it with the OpenStack deploy through Fuel. You can follow the following link. I'll show you there. This is the Fuel documentation as part of Arno in order to get it all up and running. So we've all done all these steps, configure the OPNFV environment. All this is done, and once the Fuel environment is deployed, we need to run a few scripts by going to these folders on the control and compute nodes to ensure that the ODL is started and is integrated with OpenStack. An important point to note here for any potential user is that these deployment scripts that kickstart ODL in a Docker and integrate with OpenStack, these are not really that refined right now. So you may run into many problems, and I even asked Daniel from Ericsson, and he said that the entire process would improve as we get more builds in the future. So it's very rudimentary, it's very experimental, and it might not be that functional.
And I have a question on the ODL part. Is ODL installed during the pre-deployment script run? Or?
Okay. I'll answer that. ODL is not installed through the pre-deployment script. What the pre-deployment script does is that it leaves a few files on the control and compute nodes once the OpenStack installation all is done. Just a few scripts. These scripts can be seen here in the documentation. What you need to do is to go to these directories and manually run these scripts. So once you run these scripts manually, ODL would start them.
Okay, thanks.
Okay. Unfortunately, since we don't have a Fuel deployed system, and since we just began the Fuel deployment, we don't have a system so that we could show you these files. But they would be there once you have all these things done. Okay, so that's it for Fuel. We'll now move on to Foreman. Any other questions?
I have a question.
Yes, please.
I wanted to know, like, so ODL, is it like installed inside the fuel node, or is it like a separate VM we are running ODL on, or?
Okay. So yeah, as I just answered, what happened is that on one of the control nodes, once the fuel installation is done, we can go to one of the control nodes, and you will find a script there that starts ODL. You need to manually run that script. What that script really does is that it runs ODL within a Docker on one of the control nodes.
Oh, so we are running ODL inside one of the control nodes and not as
Yes,
a separate VM.
exactly.
Can I, like, if I want to run ODL on a separate machine, is that possible? Or I have to run it on?
As part of Fuel Arno, you have to run it in a Docker, because that's the way the entire ISO is packaged and the entire installation takes place, I guess.
And there is no extra networking steps which I need to set up for ODL. It's just inside the control, so it's just running that script.
Yes, a couple of scripts. I'll just go again back to my documentation. What we need to run two scripts. The first script is this one, as I highlighted. What it does is that it starts ODL within a Docker. Once this is done, you can access the ODL GUI following your IP address, and then you need to run another script. Again, it will be just next to the stage ODL.sh script. What this script would do is that it would make the necessary networking configurations so that ODL could integrate with OpenStack.
Okay. The reason actually I asked this is I have tried integrating OpenStack and ODL with the fuel setup, but I was running my ODL on a separate machine and I ran into a few other issues. That's why.
Yes, exactly. So I asked Daniel, who packaged all this up, and he said that it's very rudimentary right now, but hopefully it would improve in the coming weeks.
Okay, thank you.
So moving on to Foreman. We already have the Foreman pod deployed on our pod 2. So I'm just going to give you an overview of the necessary things that you need to ensure from a hardware point of view so that Foreman could run. And again, I'll also tell you about the basic scripts that you need to run to set up a Foreman environment. Once we go through it, we'll use the Foreman pod to run a few fun tests. Okay, so moving on. So yes, the prerequisites for running Foreman is that you need to have at least 4 network ports in a specified order. It's very critical to have these ports in a specified order. Your first port should be the admin network for Pixie booting the pod nodes. Your second network should be for the private and the storage network for your pod, for your Foreman pod, and your third port must be for your public network. And you also need another port to ensure that the remote access controllers for all the nodes are accessible. All these conditions are necessary for all the nodes and also for the jump server. Because the jump server is the place where you're going to run the deployment scripts so that the whole pod can be deployed. Again, I'll show you what really happens here is that we have a jump server here. We have the rest of the nodes that need to be deployed. We'll run a deployment script on the jump server, and the whole pod will be set. Moving on to the next slide. There are 2 ways you could really start off with installing Foreman. You can either get the Foreman ISO from the OPNFV Arno page, or if you already have a CentOS installed on your jump server, you just need to clone the necessary files, the deployment files that are needed to start Foreman installation. You can follow them, follow the links that are present in this slide. I will share this slide so anyone in the community could use it. So in our case, we didn't need to get the Foreman ISO. We already had a jump server provisioned with CentOS 7. We just cloned this repository from GitHub, and we use this repository to do the Foreman deployment. What I'll do right now is go to my jump server for my Foreman jump server and show you the files that are needed to kickstart the Foreman installation. So again, opening up my terminal, so this window, yes, I'm going to close this session, going to start a new terminal. I'm going to go to my Foreman jump server.
Hey, Norman.
Yes, Vijay.
Yeah, I think you're doing very well. Just
Well,
a reminder, it's about 9:40, so maybe slightly faster pace.
I'll just quicken things up now. Okay, so the BGS background folder that you can see here is the repository that we cloned from this link. So this is the only folder that you need to kick off the installation, as it's going to contain all the necessary files. So going to BGS backend file, ls. So you can see here that we have the deploy.sh script here. We just need to run this script with the argument of this OPNFV KSGSN settings.yml. This OPNFV KSGSN settings.yml is very important. It contains all the necessary configuration, the hardware configuration for the nodes that are to be deployed using the deployment script. I'll open up this OPNFV KSGSN settings file. So the only thing that you need to do here is go to the compute keys and set the MAC address. Set the MAC address for the Pixie, for the port that is connected to the Pixie network, for the port that is connected to the Foreman Pixie network. Give the IP here for the remote access controller. Give the MAC address for the remote access controller. Give the username and the password for the remote access controller, and that's about it. You need to do this for the compute node, and accordingly, you need to do this for the control nodes too. Again, setting the MAC address for the port that is connected to the Foreman Pixie network, giving the IP for the remote access controller, giving the MAC address for the remote access controller, and additionally, for the control nodes, you also need to give the MAC address for the port that is connected to the private network. So you need to do all these things for the 3 control nodes. Again, the deployment script would identify the different nodes to the different MAC addresses here. So this is the key through which everything is identified. So you need to ensure that you've got 3 controllers with 3 different names, all the different MAC addresses, and that's about it. Once here is done, you can run the deployment script. I'm not going to run the deployment script here because it's going to take around about 2 to 3 hours, but that's about all the settings that you need to do to start the installation. Okay, so going back to my presentation. So yeah, again, another step that we need to ensure is that all the nodes that are to be Pixie booted have the Pixie setting on their ports that are connected to the Foreman Pixie network, and this device should be first in the boot sequence, so that the first thing that it gets booted from is Foreman. Moving on. So configuring deployment for the test server. We've done all these things before in the OPNFV KSGSN settings YAML file as I showed you on my terminal. In MAC addresses, the remote access controller IPs, all those things. I'm going to quickly go through this. Running the deployment script, I have shown you how to do this too. The deployment starts, continues for 2 hours, deploys OpenStack, set up with ODL controller. So what the deployment really does here is that it starts up a VM using VirtualBox through a Vagrant file. This VM fetches the necessary files such as Foreman to set up the Foreman. It also fetches the Khaleesi framework, that is all the automatic installation. Khaleesi consists of Ansible calls made to the Foreman API to deploy the pod. Okay, so we already have the format set up on our pod 2. So I'm going to go to my Foreman GUI. For this, we need to identify what is the IP address for our Foreman VM. So fconfig, right now I have SSH into my Foreman VM, the VM that was set up by our deploy script. Fconfig, the IP address is 172.18.0.12. I'm going to enter it in my browser. In any case, if anyone has any questions related to Foreman, I think it's the best time to ask them because we have him here on the call too. He has done all the development as far as for the Foreman side is concerned. So I think we will.
I have a question. Hi.
Sure.
Hello. Yeah.
No, yes.
I was wondering if we had to run this within a VM, like within VirtualBox, the ISO for Foreman, or is it on bare metal?
Okay. Okay, I'll explain that again. Going back to my presentation, what we need to do here is that we could either set up an ISO in a VM, but we can also do is that we could do a bare metal deployment. What we have done in our case at Dell is that we already had a system provisioned with CentOS 7. We used this system as our jump server. The only thing that we did is that we cloned this repository. On our jump server, so I unzipped the repository. I'm into my directory, and we have all the files here, the deployment script and the .yml settings file that we need. We just need to run this deployment script. The deployment script would itself set up a VM on the jump server.
Okay.
Which would have the Foreman GUI, Foreman installer, and everything. So we don't need to do anything. So it will all be handled by the deployment script here.
Okay. Thank you.
Okay. So okay. So entering my GUI. So we already have had a foreman pod set up here. Everything is running good. I'll just show you how to access the OpenStack Horizon dashboard. I'll go to configure global parameters. I mean, there are other ways to go about it too, but this is the one that I like to choose. So in our global parameters, we have the values for the parameters that OpenStack uses. I'm going to go to my second page.
So, can you guys hear me okay?
Yes, we can.
So it's worth noting here that all of these parameters are going to be fed in as OpenStack parameters, and they're all dynamically figured out at runtime. So when you run deploy, it figures out these parameters for you, and it tests to make sure that these IPs that are being allocated for those variables are available and not in use.
Exactly. Everything will be handled by the deployment script on its own. So a user doesn't really need to worry about all these.
So one more question here. Unlike
Yes.
Fuel,
Yes.
which takes the OpenStack install with I think default plugin, OES plugin. Here, do you specify that you are using ODL plugin in the beginning itself as part of installation?
We don't. As a normal user, you don't need to specify that. You don't need to run any of those scripts or specify how if to install ODL or not. When you run the deploy script, ODL will come along it.
So there's a flag in the inventory YAML file for Open Daylight. If that flag is set to true, which it is by default, then it will install Open Daylight and use Open Daylight as the neutron driver. If you set it to false, it won't install Open Daylight, and you'll just be using traditional ML2 plugin for your neutron driver.
Thank you, Tim. Okay, so going to the second page of our global parameters, here is my Horizon public IP. I'm going to enter this IP in my browser.
Question on the configuration parameters. On the UI, those are kind of derived, but is it possible to change configuration on the UI? Let's say if you make a mistake in the deploy.sh.
Yep, you can change it in those global parameters, and then Puppet will run the next time and update your nodes. If it's something where you already had Open Daylight enabled and it installed Open Daylight and you change that flag to be false, it won't remove Open Daylight from the node, so you would have to re-provision those nodes. But you can do that through the Foreman UI and not have to redeploy everything.
Okay.
Okay, so as you can see, we have the OpenStack dashboard here. So everything's running good. I'll now open my ODL GUI. The ODL is running on my first controller, on my OS controller 1. I'm going to see what the IP for my OS controller 1 is. So for that, I will go to my Foreman VM. Oh, sorry, I need to go to the temporary directory. Here. So I'm going to SSH to my first controller. I'm in my first controller. And its IP is 172.18.0.14. I'm going to put it in my browser. Yes, I'm going to log into OpenDaylight. So here we have the topology in Open Daylight. What we have here are the bridges, the different OVS bridges on the different control and compute nodes, all shown here on this topology. All these bridges are managed by the ODL running on the first controller. The 4 bridges here, these are the BR int bridges on the 3 control nodes and our 2 compute nodes. So 3 control nodes, 3 BR ints, 2 compute nodes, 2 BR ints, 1 for each node. And since we have 3 compute nodes, we have 3 BREX bridges. So these 3 are the 3 BRX bridges here. So this was just to show that ODL is integrated with OpenStack in the Foreman pod. So yes. Does anyone have any questions?
So there's a question in the chat. So Randy, instead of that link that Norman provided at the beginning, you could go to the Genesis repo and get the deploy script from there. It'll still pull from my GitHub, and that's just because we didn't have time to migrate everything before the release. So the plan is to migrate everything to the Genesis repo, and that should happen shortly. I just need to finish up a few patches and get everything merged.
Thank you, Tim.
The problem in the current OPNFV CI environment is that when you make a change into anything that's a deploy script, the Jenkins verification system doesn't actually verify that the deploy works. So it's kind of dangerous to just commit stuff there and see what happens. So I have been testing it by myself on my GitHub up until now, but we're going to change that in OPNFV CI to add that support.
So Norman, I think your next is some of the tests, right?
On tests.
Yeah.
Yes, exactly. So so now I've just shown that the Foreman pod is good. It has OpenStack running and ODL running. Now I'm going to go run a few func tests on the Foreman pod. So going to my terminal where I have opened the jump server, the Foreman jump server. I'm going to go back to my, right now I have the OS controller, going back to my jump server. This is it. On my phone. So going back to my presentation. For func tests, you need to clone the func test repository, again, which you can get it from Jared by following the following link. I have already fetched this repository. So yes, this is the func test repository that you get after cloning from the link that is provided here and again available on the Jared repository. So once you get the link, once you get the repository, first of all you need to fetch the OpenStack RC file so that the func tests could play with and could access OpenStack. So for that you need to open your Horizon dashboard, go to projects, access and security.
Actually, you can also do that if you connect to this Vagrant VM and also to one of the controllers manually SSH, and you just collect this file. It's called Keystone Admin or something like that. You can also do that.
Yeah, thank you. Yeah, yes. So fetching the necessary file, download the OpenStack RC file by going to the API Access tab. So that is how you fetch the necessary file. I already have this file on my jump server, so I don't need to get it again. So I'm going to source my OpenRC file. It's going to ask, source. It's going to ask for my OpenStack password, which is yes. So here we have. So I'm going to go to my funtest directory, go to test cases. By the way, all these necessary steps are available in the funtest Arno documentation. So if anyone likes to see them, they're very well elaborated. So entering my test case directory. First of all, we need to fetch the necessary tools that funtest uses to run all the tests. To fetch all these tools, first of all, we need to run the Python config funtest.py. This Python script, by giving the argument of the file path to our funtest repository, which in our case is funtest and press start. I'm not going to press start here because fetching all the necessary tools again takes around about 15 to 20 minutes. I have all the necessary tools with me. The tools that we'll be using.
Nauman?
Yes.
Just to mention that this script is actually preparing all the tools, installing the Rally stuff and everything that you need. Also according to this YAML file, which is located in the same directory. So it's kind of preparing the things to run the tests.
Yes, exactly this one. Yes. So yes, thank you there. Opening up my presentation. What this file as again mentioned, it helps us fetch the necessary tools such as Rally, Tempest, vping, Robot, and the necessary glance images to run the funtest tests. So we have all the tools with us. Again, running tests. This link again points to the document, the Arno funtest document. If anyone wants to give it a look.
Yeah, maybe.
Moving on. First of all, we can run a few.
Yeah, so Nauman, I'm going to, like, in the interest of time, maybe we can run the quick tests and leave the alone so that we have some time for Q&As in the end.
Okay, I'll just jump over to the test now. The Rally tests take a lot of time, so I'm going to run the vping test. The vping test is very simple. What the vping test does is that it would create 2 VMs in OpenStack along with one network. It would assign IPs from the created network to each of the 2 VMs and do a ping test between them. I'm going to run the ping test now. Going back to my jump server. Going to the vping directory.